Hey everybody, today I just wanted to do a quick video on clusters in LabVIEW. So we'll talk a little bit about what clusters are, how you can work with them, what the advantages are, all of that stuff. So first off, you can find your cluster related functions up here in your functions palette. So you'll go to cluster class and variant, and you've got your cluster related functions here. So basically a cluster is a way to collect a whole bunch of different elements together, and they can be of varying data types. So for example, I'm going to just drop this cluster constant, and it's basically just a box. So I can then go and add whatever I want into this box. So let's say I add a DBL numeric, and I'm going to add a label to it. Let's call this data. So I'm going to drop that in there. And it doesn't just have to be all the same data type. So I can take like a string, for example, and maybe this is my serial number. I can drop that in the box. And let's add one more thing. Let's add just this boolean value and call it, pass fail. And I'm going to drop this in. So I've defined my cluster, and probably should have prefaced this. This is very similar to your tuple or tuple in Python, where it's basically a collection of different data types. So it differs from arrays in that arrays allow you to have a varying amount of a single type of item. Clusters allow you to specify a specific quantity and data type of items, but collect them all together. So we have our cluster defined here. Now there's some styling things I wanted to show you. So if I select my cluster and right click on it, there is this auto sizing option. So there's a few options. You can do size to fit, which is basically just going to make the cluster fit around the stuff exactly how you've laid it out, which is sometimes nice for like front panel stuff. Typically on the block diagram, I want it to arrange either horizontally or vertically. So it'll automatically organize the stuff inside of the cluster for me. So I'm going to do vertically. You can see it automatically kind of cleaned it up, scooted everything to the edge, and shrunk that down. So I definitely recommend you organize your stuff, at least to some degree. It makes your code much more readable. So now we have this kind of interesting looking wire. It's pink, and this actually is the cluster data type. So from here, we can't do a lot of the stuff with these things individually until we break apart this cluster. So to do that, we have this unbundle by name function, or unbundle. So if I drop the unbundle by name, I get basically the thing that I want to extract. I can click on it and I can change what it is that I'm extracting, but I also can drag down and extract more than a single item. So if I wanted 1 or 2, I can do that. So that way I can, pull these things apart, maybe, change values, do stuff, and then put it back together. Now the unbundle function works very similarly, only that it doesn't use the naming. So as you see, it automatically mapped everything, but none of them are named. It does show the data type of each one, which in this case makes it easy to identify what is what, but there are a lot of clusters that will have the same data type on multiple items, and it makes knowing which thing is which a little difficult. So I can always open context help on this wire, and it shows me exactly what's what, right? So I've got data, serial, and my pass fail. So in a lot of cases though, I try to avoid just using the unbundle, because this is much more readable. I can look at my code and I can see exactly what's what. And if I want to, right, I can, click on these things and I can change it to something else, et cetera, et cetera. So I typically will try to always use the unbundle by name, unless there's an application where it just doesn't really make sense, which there are a few. that's how we can break our thing apart, our cluster apart, not our thing, sorry. Now let's look at how we can build it back together. So just like the unbundle by name and unbundle, we have bundle by name and bundle. So let's drop the bundle by name. So you can see we have inputs on the left, and I can wire stuff over, and it will accept it, but there's no names appearing. So this will allow me to create a cluster, but because there's no naming, it's actually broken. So what I have to do is on top, there's this input cluster option. So I need to tie in the type of the cluster that I want to bundle. So if I wire this over here, you'll notice everything is now mapped. And I'm able to output my cluster. So I can then, in here I could update values, etc., and then move on. So that is the bundle by name. Bundle, again, works exactly the same. So I can specify the input type, and it's, instead of showing names, just going to show data types, but it works the same. And again, just like the unbundle, I typically try to do everything by name, just because it makes this so much more readable. I can look at my code and I can understand what's going on. Okay, now another thing to be aware of. So when we are connecting the input cluster here, we are doing a little more than just defining the data type of the cluster. So for example, I could copy this and use this to define my cluster, which is totally fine. But let's say maybe my serial number was 1, 2, 3, and let's break these wires here. So let's say I only want to, so my serial number is already set. I just want to be able to set the result and whether that was a pass or a fail. So, yeah, I'm actually not gonna, whoops, didn't mean to do that. I'm actually not gonna read the data either. Let's just write a random number. Whoops, let me get that out of there. Random number. Yeah, so we're gonna do this, and it is here just to see the cluster going across. I'll connect serial. Not that it's really doing anything here. So yeah, let's say I'm doing that, and let's say I'm seeing if this is greater than. We'll just set the threshold to 0.5. So anything that's in this cluster in this scenario is going to be lost. So I'm not continuing this wire across. I am outputting the serial, so that's being transferred across. If I were to not do that, this is no longer connected to this at all. So just one thing to be careful of is, yeah, just because these are the same data type and they look the same, once this wire is no longer connected to the inputs on the bundle, these are no longer connected. So yeah, but yeah, this is basically how we can work with clusters. So yeah, I can take all that data and run this, and we see our data, we see our serial number, and we see we were above 0.5, so we passed. So cool. And just to highlight clusters, they also work on the front panel. So I can go to data containers and drop a cluster, and I can add to that cluster, anything that I want, basically whatever data type, as many elements as I want, etc. So, and yeah, another thing to highlight is if you're working with a lot of custom clusters that you've created, I highly recommend that you make them a type def. So you can do that if you've already laid one out just by right clicking on it and going to make type def. You're you're going to see that this little triangle icon in the top left corner. That's how you know that it has been marked as a type def, which means you now have, and I can go to open type def, a control that basically defines the data type of this thing. Now I'm just going to save this. Let's just call it demo control. All right, sweet. So now I basically have a type def which defines the type of this cluster. So there's a good chance that the data that I've defined may change over time, and I may need to add something or take something from this cluster. So let's say maybe now I need to add another numeric called maybe upper limit, and let's add one more for lower limit. Sweet. So I can just go into my type def and click save, close out of this, and you notice this, because it was linked to my type def, automatically updated. So everywhere in my code where that where controls, indicators, constants are linked to that type def, they will automatically update. If you notice, this is broken, and that would be because this is not linked to that type def. It's still the original data type. So it broke that. Now, had it been linked to the type def, I actually wouldn't have had to change anything. This would have automatically updated. So for code maintainability and whatnot, it definitely makes sense to type def your clusters. And now we have these new values that I just added, so you can see I have upper limit and lower limit. So yeah, that's the basics of clusters. It's basically just a collection of a whole bunch of different data types that you can specify what they are. You can extract different elements and you can basically write them back. Like I said, just a couple of takeaways. Highly recommend that you use unbundle by name and bundle by name when you are working with these. That you organize your clusters. Some stuff on the front panel I won't organize just because I want it to be laid out a certain way, sometimes with space and whatnot. But anything on the block diagram, I always organize. And then let's go back to our type def and just show you one last thing. So I'm going to open this up. Actually, I'll show you after this. The last thing I wanted to show was basically how we can reorganize this cluster. Whoops, I'm in edit mode. So if I right click on my cluster, there's this option here for reorder controls in cluster. So if I want to change the order of these things without having to just delete stuff and re-add stuff, I can click this. And basically what this does is this allows me to change the order of all of these things. So I can see that this is 0, this is 1, 2, 3, 4. And it's telling me to click to set to. Now I can type in a number that I want and click on the thing, or it will increment for me as I go. So let's say I want to set lower limit to be the first thing. So now it says it was 4, now it's 0. And now this says click to set to 1. So I can click here. Now it was 3, now it's 1. This, and that. It actually automatically selected that. Then I can either cancel or I can confirm, and you can see it automatically reorganized everything in my type def for me. So I now have a completely different order. So if I just want to change the order of those things, it's pretty easy. One last thing I wanted to show, if you have a cluster that is tied to a type def and you want to remove that, you can just right click on it and click disconnect from type def. And that's just going to turn it back into basically a regular cluster. So it's no longer synced up to that type def, where if I make changes to the type def, it will change here. But yeah, that's basically the crash course on clusters in LabVIEW. Thanks for watching, and I hope that was helpful.
Canon Controls is your gateway to mastering LabVIEW. Dive into programming for data acquisition, industrial communications, and manufacturing automation. Explore how to enhance your projects with cybersecurity best practices. Join the journey to elevate your skills and secure your systems with every episode.